Welcome to Brain Vision.
All right, here we have a triangle um, with a piston between 2 points. Point A and point B have to follow certain tracks, a vertical track for B, horizontal track for A. We have initial positions and initial length of the piston here, such that the piston is 0.75 meters long, but it's increasing at a rate of 0.2 meters per second. The velocity of A is 0.6 meters per second. Theta is 35 degrees initially. We want to find the velocity of B here. So to do that, we'll have to do a little bit of geometry first. So we know that by Pythagorean theorem that xa squared plus yb squared will have to equal that length squared. So that's fairly simple. We can take the time derivative of this. If we take the time derivative, this will give us 2xa xa dot, which will just be the velocity of A, plus 2yb times the velocity of B. And that will equal 2L times L dot. So if you'll notice, we've gotten a lot of the information we need here. We can solve this for that velocity of B that we're looking for in this problem. So the velocity of B will just be L dot minus XA VA, and then this is divided by that position YB. So if we can find all of this, we can find our velocity B. So we need to find a couple things, that position XA and the position YB. So we'll start with finding XA. And to do that, we can look at a simple triangle using the sine of theta. So the sine of theta will equal XA over L. Well, we know what theta is, so we can solve this for XA pretty simply. XA equals L times the sine of theta. L was 0.75, theta was 35 degrees. So we get XA is about 0.430 meters. We can do something similar for YB. We can either use the cosine or we could use the Pythagorean theorem. Up here, we already have the Pythagorean theorem written down, so I'll just start with that. So YB equals the square root of L squared minus XA squared. If we put the numbers in, this should give us about 0.614 meters. We can then put these numbers into our velocity equation. We have 0.75 meters times 0.2 meters per second minus 0.43 meters times 0.6 meters per second, and divide that by that 0.614 meters, and we end up with a negative 0.176 meters per second. So that means that object B here is moving down with a velocity of 0.176 meters per second.